Oh, oh my goodness. Sorry about that. Okay. So, algebra notes for 7-3. This is kind of solidifying the exponential growth from lesson 1 and the exponential classwork growth or decay from lesson 2 and kind of smushing them into one general exponential equations. So, in general, exponential functions will always have a variable as the exponent, hence exponential functions. Exponential functions will always have a variable as the exponent. Oh, I feel lazy. And not to confuse, something like t squared, not exponential, because the variable is not an exponent. The exponent is 2, not a variable. X cubed, not an exponential. The exponent is 3, not a variable. So just like with linear equations, we have that equation that y equals mx plus b. Exponential functions have an equation as well. The equation that you're going to want to memorize for exponential functions is y equals a times b raised to the x power. Just like with y equals mx plus b, when we write that equation, all pieces don't get filled in. We only fill in the m for that slope and the b for the y-intercept. When we're looking at an exponential equation, you're only going to fill in, or you're only filling in numbers for a and b. Just like y equals mx plus b, the x and y stay as x and y. In this equation, that x and y are going to stay as x and y as well. Keeping in mind that, they're not always going to be x and y. There can change. It could be, h and t, whatever different variables they want. So when we're looking at this, the a value is what's called your starting value. Another name for starting value is that initial value, right? Initial makes us sound smart. And just another name for that starting value or that initial value is that y-intercept, that 0, a. Kind of confusing because in y equals mx plus b with linear ones, b is the y-intercept. And in this case, b is not the y-intercept. In this case, b, or that number being raised to the exponent, aka the base, that base is better known as what's called a multiplying factor. You could also have this called, instead of a multiplying factor, you can call it a growth factor or a decay factor, depending on which situation. Obviously, if it's growth, you would be using growth and decay. The important thing is that the b, the base, the number you're multiplying by, it's never going to be equal to 1. Not equal to 1. And that's because if you think about, 1 being raised to some power, 1 to the second power is going to be the same thing as 1 to the 200 power. 1 times 1 is still going to be 1, even if it's 1 times 1 times 1 times 1 times 1 times 1 times 1 100 times. So that's why we're never going to see a base of 1, because it wouldn't really do anything. It's not going to change anything. It's going to give you the same answer over and over and over again. Boom.